Hello friends, today's question. Two soap bubbles A and B are kept in a closed chamber where the air is maintained at pressure 8 Newton per meter square. The radii of bubbles A and B are 2 cm and 4 cm respectively. Surface tension of the soap water used to make bubbles is 0.4 Newton per meter. Find the ratio of NB to NA, where NA and B are the number of moles of air in bubble A and bubble B. Neglect the effect of gravity. So in this case, it is given there are two bubbles A and B which are kept in a container, closed chamber rather. Outside pressure is 8. So we are going to use standard equation which says that difference in pressure is equal to 4 multiplied by the surface tension divided by the radius. Okay. So first of all, based on that equation, we can say we are going to determine what will be the internal pressure, because the external pressure in this case is given as 8 Newton per meter square. Normally, because it is kept in the closed chamber, if it is in open, you can say open environment, then the external pressure will be the atmospheric pressure. That's the only difference here. So we can say we determine the internal pressure of each bubble. And we know that in case of soap bubble, the pressure difference across the surface due to the surface tension sigma is given as 4 sigma divided by R. So you can write in a soap bubble, the pressure difference across the surface due to surface tension sigma, it is given as delta P is equal to 4 times sigma divided by R, where R is the radius of soap bubble, and sigma is the surface tension whose value is given to us. Sigma is given as 0.04 Newton per meter. So let us remodify this formula for bubble A as well as bubble B. Therefore we can say for bubble A, it is given that radius of bubble A is our 2 centimeter, 0. meters, and external pressure will be same in both the cases. So you can say P external will be equal to 8 Newton per meter square. So we can write that delta P is equal to, rather we can delta PA will be equal to 4 into sigma is 0.04 and radius is 0.02. So delta P for A is our 8 Newton per meter square. So pressure difference delta PA the pressure difference delta PA will be equal to pressure inside, that is PA minus pressure outside, and PA is the internal pressure. So we can write here internal pressure PA will be equal to delta PA plus P outside. Okay. Here I have written P external, let me write it P outside. So P outside and P external are same. We substitute the value, we get internal pressure PA will equal to 8 plus 8, that equals 16 Newton per meter square. Similarly, we are going to solve for bubble B also. So you can say for bubble B, we are given the radius of bubble B is our 4 centimeter, which is 0.04 meters, and in this case also we are going to have that pressure outside, which is nothing but external pressure, is once again it is given as 8 Newton per meter square. So you can write that delta PB will be equal to PB minus P outside, and PB is internal pressure. PB will be equal to delta PB plus P outside, and delta P I forgot to calculate. Delta PB will be equal to 4 into 0.04 divided by 8, and radius is 0.4, my mistake, and this comes as 4 Newton per meter square. Okay. So delta PB is our 4 external pressure is given as 8, this comes as 12 Newton per meter square. Now it is given the question that it is a closed chamber. Okay, so we can ideally assume that it is a ideal condition, so we can use the ideal gas law. So you can say applying ideal gas law, which states that PV is equal to nRT, where n is the number of moles. So we can write n is equal to PV upon RT, where P is the, you can say, pressure, V is the volume, and we have T is the temperature, and R is the Avogadro's number. We are going to write the volumetric equation for both bubble A and bubble B. You can say for bubble A, VA will be equal to 4 by 3 pi RA cube, and for bubble B, VB is equal to 4 by 3 pi RB whole cube. So we got the formula for volume as well. This now we are going to modify this equation for bubble A as well as a bubble B. So therefore we can write that for bubble A, NA will be equal to PA VA upon RT, and for bubble B we can write NB is equal to PB VB RT. We are supposed to find out NB by NA, so we divide them. So we can write that our NB upon NA will be equal to, we are going to get this as PB VB upon PA. VA, RT and RT are going to cancel out. We substitute the value of volume as well as for A as well as B. So we get this pressure of B, pressure of A, and volume of B is our 4 by 3 pi r B cube divided by 4 by 3 pi r A cube. These two terms cancel out, so we get NB upon NA is equal to PB upon PA multiply by, we get this as RB upon RA whole cube. We simply substitute the value. PB we have our 12, PA we have 16, radius of B is given to us as 0.04 and A is given as 0.02 whole cube, and this comes equal to as 6. So we are supposed to find out the ratio. So you can see NB ratio NA will equal to 6:1. So this is the ratio of NB and NA, that is the number of moles. This is the ratio of number of moles in the bubble B to bubble A. Bubble A. So this completes the question. Thank you.